Good afternoon, student. Today's class is last class for this chapter. Uh, Fourth weekly test will be held on 23rd August. Uh, I had a plan for taking exam 30 August, but 30 August is a holiday for Janmashtami. So your fourth uh, test exam, online exam, will be held on 23rd August. Okay, so I must to finish this chapter by today. Okay, so I'll try to finish chapter today, and I'll take this class quickly. Okay, look at a glance this periodic table. This is a periodic table. Look, group 1, group 2. Group 1 element hydrogen, lithium, sodium, potassium. Group 2 beryllium, magnesium, calcium, strontium, barium. And group 3, group 4, group 5, 6, 7, 8, 9, 10, even 13, 14, 15, 16, 17, 18. Group 18 is the noble gases. Group 17, fluorine, chlorine, bromine, iodine, they are halogens. Okay, look there in the bottom, in the beneath of the periodic table, there is another two rows. This atomic number 59, 57 to 71. This rows is called Lanthanide series group, and this group is atomic number 89 to 103. These are actinized groups. Okay, this color, look, color, this is blue color. It is not actually they design periodic table here, design given alkali metals given purple color. Alkaline earth given this regions, this color, and transition metals given which color? Sky blue color, transition metals. And basic metal are given, this basic metal is given this color, and semi metal given green color, and non metal are given by blue color, and yellow color halogens. Fluorine halogens are given yellow color, and orange color is given for halogens, noble gases, orange color, and light green color is lanthanide. And this what color? It's different color. This actinized series is given red purple shadow. So I am taking class today. This is this elements period 1. This rows is period 1. This second lithium, beryllium. This is the period 2. Beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They are period 3 elements. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. They are period 3 elements. Lanthanide, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They are period 2 elements. Okay, now I am going to start today's main topics. I am going. So I must to finish today's chapter quickly, and there will be exam on 23rd August. That means next week your exam will be held, online exam will be held on chapter 4. So I must finish this chapter by today and by 1 a.m. Okay, this the main basis of the periodic table. Do you know what is the main basis of the periodic table? Mass of elements or weight of elements, or there are many bases of elements: base, electronic configuration, and main basis of electronic configuration, main basis on which the electronic periodic table was made. Main basis of electronic for periodic table is the electronic configuration of elements. So electronic configuration of elements are the main basis of the periodic table. Look at the electronic configuration. Look at hydrogen. Hydrogen is electronic configuration 1s1. It is shell number is 1, so period number 1, and outermost shell electron is 1, so group 1. So the electronic configuration is main basis of the periodic table. Like lithium 1s2 2s1 s orbital. The shell number is 2 here, 2 shell, highest shell number 2, so period 2, and it's s orbital electron. So outermost shell is 1 electron, so is group 1. Sodium, outermost shell electron is shell number is 3, so period 3, outermost shell is 3, here 1 electron, so it is group 1 and period 3. And beryllium, these are group 2 elements. Beryllium 1s2 2s2, period outermost shell is 2, and so period 2, and outermost shell is 2 electrons, so it is group 2. Electronic configuration serves to identify group and period of an element in the periodic table. Again, elements having same electron arrangement in outermost orbit belong to same group. On the other hand, elements with different electronic configuration of electrons in their outermost shell belong to separate groups. The elements with 1 electron in the outer shell generally tend to give away the electron and become positive ions. The elements with 1 electron in the outer shell generally tend to give away electrons and become positive ion. Sodium has 1 electron in the outer shell, so it donates the electron and become positive ion. So the elements with 1 electron in the outer shell generally tend to lose electron and become positive ions. So in the outer shell is 1 electron. Like sodium, we know this sodium 281, outermost shell electron is 1. Like sodium, if I draw electronic configuration using Booth's model, sodium electronic configuration will be this way. How many electrons in the outermost shell? First shell is 2 electrons. I should give I kept giving cross also, no problem. I am giving here dot. In first shell is 2 electrons. Second shell 8 electron, and in the third shell, second shell 8 electron, and the third shell that is outer shell, it's 1 electron. So the outer shell is 1 electron. Okay, is it which one is possible, which one is perfect for sodium? Either losing 1 electron to become 8 electrons or gaining 7 electron. Which one is tend? So, it's more possibility for sodium. Possibility more for sodium losing is or gaining. if it losing is easier or gaining easier, how can it gain its octet? 8 octet, that means 8 electron in the outer shell. This electronic configuration of noble gas to become stable. So which one is easier? 1 electron losing become 8 electrons, it is easier, not or gaining 7 electrons for sodium, which is more tend, more possibility for sodium. Hello, losing electrons or gaining 7 electrons? So which one? And for chlorine we know this 17 electrons. Chlorine is 17 electrons, atomic number 17. So proton number 17, we know in a atom proton and electron number is same, so electron number also 17. So here is a 287. So how many electrons in the outermost shell? Chlorine 7 electrons. So this is first shell, second shell, and third shell. First shell is 2 electrons, second shell 8 electrons, 8 electrons, outermost shell electrons 7 electrons. Hello student, unmute everyone. Unmute. Okay, it has chlorine has 7 electrons in the outermost shell, and sodium is 1 electron outermost shell. How can it gain octet? Losing electron or gaining electron? Which one is easier? Which one is easier for sodium? Losing electron or gaining electron to gain octet? Hello student, unmute and give if it want to gain electron, it need to gain 7 electron, then it will be 1 electron here, so it need to gain 7 electron, then it will be able to gain octet. So 7 electron need to gain. Here it need to if you want to lose 1 electron, if it lost 1 electron, it gain easily octet. So if we lost 1 electron, it gain easily octet. So which one is more possible, is more possibility, losing or gaining to gain octet for sodium? Hello, student, are you listening me? Which one is more possibility, losing or gaining for sodium?
Losing.
Yes, it একটা যদি লুজ করে যায় দেখো সে অক্টেট গেইন করে দিব, ঠিক না? একটা এদের একটা লুজ করে দিল, শেষ, এটা শেষ করে সে কিন্তু অক্টেট হয়ে গেছে, দেখছো? So losing is easier for sodium, so it lose 1 electron and become octet. So sodium if lost 1 electron, sodium will lose 1 electron. So it become 1 positive charge ion. Why it become positive ions? Positive ions, we know this in a atom electron number and proton number is same, like is proton number is, when it don't lose electron, proton number is 11 and electron number is 11. When it lost 1 electron, then proton number remains same 11, but electron number, how many electron number? When it lost electron, 1 electron, electron number becomes, Which one is electron number becomes now 10 because it lost one electron. When atom is neutral, proton number and electron number is same. When it lost one electron, electron number become 10 and proton number 11. So proton number is more, positive is more. So positive, and how much more? 1 positive. So 1 positive sign. So it become positive ions. Sodium, when sodium lost one electron, it become positive ions. 1 positive ion, and it will it has more possibility to gain electron, because if it gain one electron, it become octet. If it want to lose electron, you have to lose 7 electron, but it is easier gaining 1 electron to gain octet. So sodium chlorine will gain electron. Chlorine will gain electron. Gain electron. Okay. Chlorine proton number is 17 because atomic number 17. So in a neutral atom, proton and electron number is same. So electron number is 17. When it gain 1 electron, proton number is remains same. Proton number remain same, 17, and electron number become 18. So negative is more, so it will be negative ion. Chlorine will be negative ion. How much negative is more? 1 more, so 1 negative ion. So this chloride ion is formed. So chlorine, the elements with 1 electron in the outer shell generally to give away loss the electron to become positive ions. Sodium has 1 electron in the outer shell, so it donates the electrons and become positive ions. I can write this negative sign. If I write this negative sign sodium in the right hand side, this negative sign will be positive. If I write this left hand side minus E, in the right hand side it will be plus A. If you this can, that means it means lost electrons. I can write this is written here in book. So again, elements with the electrons in the outer shell, elements with 7 electrons in the outer shell generally tend to accept an electron and become negative ions. Chlorine has 7 electrons in its outer shell, so it accepts 1 electron and become a negative ion. So electronic configuration help us to determine the position of an element in the periodic table. So electronic configuration help us to determine position of an element in the periodic table, and it's also explain their various characteristics as well. It is positive ions, it is metal, it is non-metal. So we find the properties of elements from electronic configuration as well. Therefore electronic configuration is considered as the main basis of the periodic table. So why electronic configuration is considered as the main basis of the periodic table? This is one most important question. I may give this question in the upcoming exam, which will be held on 23rd August. Okay, some exception in the periodic table. Some exception. We know hydrogen is non-metal. However, the periodic table display hydrogen alongside with strong alkali metals. Hydrogen are placed in alkali metals like sodium, rubidium, cesium, francium group in group 1. Hydrogen is metal, but it is placed with the non-metals electron. Hydrogen is non-metal, but it is placed with metals like sodium, rubidium, cesium, francium in the periodic table group 1. look at hydrogen is non-metals. Non-metal are in the right hand side, should be placed in the right hand side, but it is hydrogen is placed in the left hand side. Here this metals, left hand side, this is alkali metals. So it is a, what is this thing, 10 minutes. It is one exception of the periodic table. Hydrogen is non-metal, but it is placed in the, hydrogen is non-metal, it should place in this right hand side, but it is placed in the left hand side with the alkali metals group. This is the look, it is a blue color, but it is placed in the with the metals. It is why this was done. Have you understood this? This is the exception. Why so hydrogen is placed with the metals, group 1 metals. Chat. So please send us that colorful periodic table on WhatsApp. Send us that, this one.
Sir, this one.
Okay, I'll send it. Okay, this one periodic table. This is exception. Hydrogen is non-metal, but it is placed with the metals. Why? Because the outer shell of hydrogen contain 1 electron. So 1 electron, that means group 1 alkali metals. Besides, many properties of hydrogen are similar to those of alkali metals. With this alkali metals group 1, there are many properties. On the other hand, hydrogen also be able to accept an electron like halogen elements group 7, meaning it has some similarities with halogens in terms of properties. However, it also some properties with halogens group 17 elements. So we should can we take this hydrogen in group 17, or this is group 1? এখানে মাইল লাগে গেছে, মানে কোন গ্রুপে নিতে হইবে, 17 or 1? However, since the most of the properties of hydrogen have similarity with alkali metals, for this reason it is placed alongside with alkali metals group 1. Okay, for this reason, this exception. And another position is the position of helium. Position of helium. Look at position of helium. Yeah, what is the position of helium? Position of helium is group 18, halogens. So there is another exception for the position of helium. The electronic configuration of helium is 2. So 1s2. In the outermost shell electron is 2, so it is group 2. So group 2 is should place in the with the this element, beryllium, magnesium, calcium. They are group 2, but it is placed with the group 18 elements. This is the exception. The electronic configuration of helium is 2, so 1s2, so it is outermost shell electron is 2, so group 2. But according to this electronic configuration, it was supposed to be the position in group 2, but elements of group 2 are strongly electropositive. They are called alkaline earth metals. On the other hand, helium is an inert gas, noble gases. Its properties are similar to other inert gases like neon, argon, krypton, xenon, radon, and its properties are not at all similar to the alkaline earth metals. Therefore, helium is placed alongside with inert gases in group 18. So its most properties is similar with noble gaseous, though it a group 8 outermost shell electron is 2, but its most properties similar to the inert gases. For this reason it is placed alongside with the inert gases in group 18. Now position of lanthanide series and actinide series in the group 17. Why these two series element is not placed in the main periodic table? They are placed in the bottom in the periodic table. These two series elements, lanthanide series elements and actinide series elements. Why these two elements here are not placed? If this elements is placed here, what will be periodic table? Periodic table এখানে থেকে বড় হয়ে এরকম যাবে, মানে কি রকম হয়ে যাবে না, and it is placed here in the group 6, period 6 in the yes, period 6. In this period 6 here, if we place the lanthanide series elements here 57 to 79, এটার পেট মোটা এগুলো জানি নাকি এরকম এই this actinide series. So what will be this? The lanthanide elements are supposed to be set in the period 6 and group 3. Yes, this is group 3, group 1, group 2, group 3. So they are period group 3 and period 6 lanthanide series, and actinide series they are also period group 3 and period 7. Why these elements are not placed in the main periodic table? The lanthanide series elements are supposed to be set in the period 7 and group 3 of the periodic table. The original position of actinides group is in period 7 and group 3. If they are placed in this position, that hampers the beauty of the table, periodic table, that kill, that hampers, or protect, no protect even that hampers the beauty, it lost the beauty of the periodic table, that hamper the beauty of the periodic table. Therefore to maintain the beauty of the table, those two groups of elements are moved to a separate table just beneath the main table. Okay, for this reason. Now periodic properties. Okay, less than 2 minutes remaining. I am